Millions visit Niagara Falls every year, cameras out, ponchos on, lost in the thunder of crashing water. But almost no one realizes what they're really looking at, because Niagara Falls is a machine. Every drop that plunges over that edge has already been measured, redirected and scheduled by people working miles away. What looks like wild nature is actually one of the most carefully managed hydraulic systems on the planet. Upstream, hidden gates quietly rise and fall to control the flow. Beneath the riverbed, tunnels carved through bedrock redirect millions of gallons each second. And deep inside the gorge, massive turbines hum with a steady rhythm that never stops. Not for a single day. It's all part of a vast system built to keep Niagara alive, to make sure this natural wonder never runs dry. Yet the story of how it works isn't written in stone or steel. It's written in treaties, rivalries, and human ambition. Because over the past 2 centuries, engineers have done something unthinkable. They've tamed one of Earth's most powerful forces, not to destroy it, but to preserve it. This is the hidden engineering of Niagara Falls, the waterfall that performs on command. Before Niagara Falls became a spectacle, it was a problem. A 167-foot-high curtain of water slicing through the border of 2 nations. Beautiful, yes, but utterly merciless to anyone who tried to cross it. In the early 1800s, the Great Lakes were North America's superhighway. Massive cargo ships carried grain, iron and timber across half a continent. But every journey ended the same way, at Niagara's cliff, where millions of gallons thundered into a gorge so deep and violent that no vessel could pass. For the United States and Canada, this wasn't just geography. It was an economic chokehold. Goods had to be unloaded, dragged around the falls by horse and cart, then reloaded downstream. A single shipment could lose weeks in transit. For 2 growing nations built on trade, Niagara wasn't a wonder, it was a wall. So, engineers decided not to conquer the waterfall, but to go around it. In 1829, the Welland Canal opened, a 27-mile man-made river carved through farmland and limestone. It was an audacious idea, a series of giant locks that lifted ships up from Lake Ontario, then lowered them safely past the escarpment's height. Each lock worked like an enormous water elevator, raising and dropping vessels by 40 feet at a time. When the first cargo ship passed through, the impossible became routine. Chicago grain could now reach the Atlantic. Detroit steel could sail straight to Europe. The canal turned the Great Lakes into a continuous highway, and Niagara, from an obstacle, became a landmark. Ironically, the canal also saved the falls from destruction. Some early schemers had proposed blasting a channel through the waterfall itself to let ships pass. But with the Welland complete, that brutal plan was abandoned. Niagara remained untamed, at least on the surface. Because now that ships could sail around the falls, humanity had time to look closer and wonder what else could be done with that endless surge of power pouring over the edge. And soon, the roar of the water would become the hum of electricity. By the late 1800s, Niagara Falls had become more than a natural wonder. It was a dare. All that water, all that energy. It wasn't just falling, it was being wasted. To engineers of the industrial age, Niagara looked like an untapped dynamo, a force that could light entire cities if someone could just figure out how to capture it. 2 men stepped forward with rival visions. Thomas Edison, already famous for the light bulb, believed in his direct current system, DC power, reliable but short range. It could illuminate a city block, but it couldn't travel far. Then came a young Serbian inventor named Nikola Tesla, a dreamer who saw energy as something that should flow freely, like the river itself. His system, alternating current, or AC, could send power miles away without losing strength. The world chose sides. Edison called Tesla's system dangerous. Tesla called Edison's obsolete. Their rivalry would become one of the greatest scientific battles in history. and Niagara Falls was the prize. In 1893, the contest reached its climax. Westinghouse Electric, armed with Tesla's AC patents, won the contract to harness the falls. The plan was staggering. Dig massive underground tunnels, capture water before it plunged over the brink, and funnel it through iron penstocks down 2 turbines buried deep in bedrock. Each turbine would spin a generator the size of a small locomotive, converting the river's weight into electricity. It was engineering on a biblical scale, a system designed to turn gravity into power. 3 years later, on November 16, 1896, the switch was thrown. Water thundered through the tunnels, turbines roared to life, and 26 miles away, the city of Buffalo lit up. For the first time in history, electricity traveled a long distance from a natural source, and Tesla's alternating current had triumphed. The Edward Dean Adams power plant became a global symbol of progress, a fortress of stone and copper that turned water into light. Inside, 12 giant generators spun day and night, producing over 50,000 horsepower. Soon, more powerhouses rose along the gorge, on both the American and Canadian sides, until Niagara Falls became the beating electrical heart of 2 nations. But behind the marvel, something invisible was changing. To feed the turbines, engineers were quietly redirecting more and more of the river away from the edge. By the 1940s, as many as 3/4 of Niagara's waters were flowing through hidden tunnels instead of over the cliff. Tourists still gasped at the view. The cameras still caught the mist, but the thunder that filled the valley was no longer entirely natural. Niagara had become a managed illusion, a wonder on a switch. And soon, the question facing both countries would be impossible to ignore. How much can you take from nature before it stops being nature at all? By the mid-20th century, Niagara Falls was in trouble. The power stations were thriving, but the waterfall itself was fading. Too much water was being stolen for electricity, leaving less to spill over the cliffs. Engineers had built a miracle, but they were quietly draining the very wonder that inspired it. During the day, when tourists flooded the lookout points, the roar of the falls still seemed mighty. But at night, after the lights went out and the crowds went home, the volume dropped dramatically. Pumps redirected torrents of river water through underground tunnels instead of over the edge. Niagara was performing on cue, louder by day, subdued by night, and nature's rhythm had become a stage schedule. By 1950, it was clear something had to change. So the United States and Canada sat down to negotiate a truce between beauty and industry. The result was the Niagara River Water Diversion Treaty, a landmark agreement that put nature under international management. The rules were precise. During daylight hours in tourist season, at least half the Niagara River must continue to flow freely over the falls. At night, or in the off-season, the flow could be reduced, but never below 1/4. To enforce this balance, engineers constructed the International Control Dam, a series of adjustable gates 2 miles upstream. It looks modest, just a low concrete weir stretching part-way across the river, yet it controls the heartbeat of Niagara itself. Each dawn, the gates rise, letting more water pour over the brink. Each night, they sink, rerouting flow through vast hydropower tunnels. The shallow American side acts as a natural spillway. The deeper Canadian side does the fine-tuning. But even this wasn't enough. The falls and the power grid both peaked during the same hours. Day. To keep both satisfied, engineers devised an ingenious solution: water storage reservoirs. At night, when the flow could safely be reduced, pumps lifted millions of gallons into huge artificial lakes atop the escarpment. By morning, that water was released again through the turbines, generating power precisely when cities needed it most. It was nature's oldest trick, the water cycle, reinvented by engineers. And it ensured that Niagara Falls would never again have to choose between survival and progress. For more than a century, humans had bent Niagara to their will, carving tunnels, redirecting rivers, even scheduling the waterfall like a theatre show. But nature wasn't done fighting back. On a cold March morning in 1848, locals woke to a sound no one had ever heard before: silence. The Great Niagara River had stopped completely. The roar that had shaken the valley for generations was gone, replaced by an eerie stillness. Birds circled in confusion. People ventured down the riverbed on foot. Some even rode horses where, just hours earlier, a raging torrent had crashed. The cause was as unexpected as the sight itself. High winds had pushed enormous sheets of ice from Lake Erie into the mouth of the Niagara River, forming a natural dam. For 30 hours, not a single drop flowed over the edge. It was a glimpse into Niagara's mortality, proof that even the mightiest waterfall could vanish overnight. When the jam finally broke, the roar returned. But that brief silence haunted engineers for generations. They realized that if ice could choke the river once, it could happen again. So more than a century later, they built a quiet line of defense, the Lake Erie ice boom. Since 1964, each winter, a chain of floating steel pontoons, 2.7 kilometers long, has been stretched across the mouth of Lake Erie. Its job is simple: hold back drifting ice fields before they can block the river. It's crude, invisible to most tourists, and incredibly effective. Thanks to that barrier, Niagara's thunder has never fallen silent again. But ice wasn't the only threat. Beneath the mist, another enemy was always at work: erosion. For 12,000 years, Niagara has been eating itself alive. The water pries at the limestone caprock, breaks it apart, and sends it tumbling into the gorge. On average, the falls used to retreat 3 feet every year, a geological march upstream. But when engineers began diverting water for power, they accidentally gave the waterfall a second life. With less force hammering the cliff, the erosion rate slowed to about a foot per year. In trying to harness Niagara's energy, we also bought it time. Still, the balance was delicate. Nature might have yielded, but it had not surrendered. And by the 1960s, engineers would be forced to do something even more radical: to stop Niagara Falls on purpose. By the late 1960s, engineers faced a growing fear that part of Niagara Falls was slowly collapsing under its own weight. The American Falls, the smaller cascade on the US side, had been shedding rock for decades. Each year, more boulders tumbled into the gorge, forming a massive pile of debris known as talus. It was rising fast, and experts warned that if it kept building, the American Falls might one day lose its sheer drop and turn into a long, ugly rapids. Doing nothing wasn't an option. But how do you fix a waterfall? In 1969, the US Army Corps of Engineers decided to find out by doing the unthinkable. They were going to shut it off. Over several weeks, crews dumped 27,000 tons of rock and earth into the river channel between Goat Island and the New York shore. Slowly, the water level fell. Then, one morning in June, the impossible happened. The American Falls went dry. For the first time in human history, one of the world's greatest waterfalls stood silent. Tourists gathered in disbelief. The roaring curtain of water was gone, revealing the raw cliff face beneath, scarred, cracked, and littered with coins thrown by visitors decades earlier. Engineers and geologists climbed down into the gorge, walking where no one had ever walked before. They installed anchors, cleared loose debris, and mapped every fracture. What they found was surprising. The talus pile, once thought to be ruining the falls, was actually propping it up. Removing it could destabilize the entire cliff. After months of study, the verdict came in: leave it alone. Sometimes the best engineering decision is restraint. In November 1969, the cofferdam was dismantled and the river roared back. The American Falls came alive again, scarred but standing, its thunder restored. Since that day, Niagara has never been shut off again. And for the engineers who once silenced it, the message was clear: we can command nature for a moment, but we can never own it. Stand at the edge of Niagara Falls today and it looks as wild as ever. A thunderous wall of water plunging into a cloud of mist. But what you're really watching isn't chaos, it's choreography. Every second, more than 2 million litres of water rush toward the brink. Yet every drop has already been measured, managed and directed by one of the most complex hydraulic systems ever built. Beneath the surface, the falls hides an entire industrial city, invisible to the millions of tourists who come each year. Massive intake tunnels, some wide enough to drive a truck through, snake through the bedrock beneath the river. These tunnels channel water toward two enormous power stations, the Sir Adam Beck complex on the Canadian side and the Robert Moses plant on the American side. Each of these facilities is a cathedral of engineering. The Beck stations alone generate more than 2 gigawatts of electricity, enough to power nearly 2 million homes. The Robert Moses complex matches it almost watt for watt. Together, they divert as much as 75% of the Niagara River's flow through turbines before returning it downstream. And yet, to the casual observer, the falls still seems untamed. That's the genius of Niagara's hidden design. Sensors and cameras constantly track the flow. The International Control Dam upstream adjusts its gates by fractions of an inch to maintain the perfect balance between spectacle and supply. Every sunrise, operators increase the flow so the waterfall roars for the day's visitors. Every night, they reduce it, quietly restoring the grid's demand. Even the mist and lighting are coordinated. At dusk, computer systems synchronize LED projectors with the river's flow, bathing the cascade in color while maintaining the illusion of pure wilderness. In truth, Niagara Falls is both a natural wonder and a machine running in perfect harmony. It's one of the only places on Earth where beauty and industry coexist by design. The tourists see nature, the engineers see precision, and every 24 hours that balance resets, proving that even the wildest forces on Earth can be managed, if you're careful enough not to break them. So, have we conquered Niagara Falls, or merely negotiated a fragile peace? For 2 centuries we've drilled into its rock, siphoned its power, and rebuilt its rhythm to suit our needs. We've written treaties that tell rivers when to rest and machines when to roar. And yet somehow the waterfall still feels free. That's the paradox of Niagara. It's both tamed and untamable. Every drop you see tumbling over the edge has been counted, calculated, and timed. Its thunder is a performance. Its mist, a curtain. The spectacle of nature survives today because of the precision of engineering that lies beneath it. We didn't save Niagara by leaving it alone. We saved it by managing it, by learning how to borrow power without stealing beauty. The turbines hum, the control gates adjust, the lights dance across the water, and the crowd at the railing still gasps in wonder. Few realize that what they're witnessing is not just a waterfall, but a truce, one between raw nature and relentless innovation. It's a deal that must be renewed every single day. If the engineers overreach, the magic fades. If they hesitate, the system falters. But for now, the balance holds, and the roar continues. Beneath the mist, Niagara's hidden machine hums quietly, doing what it was built to do: preserve the illusion of the untouchable. And maybe that's the most extraordinary part of all, that humanity learned not just how to harness one of Earth's most powerful forces, but how to make it look untouched. Because sometimes, the only way to protect a wonder is to engineer it.